Hello guys, welcome back. Today we'll discuss about the Kubernetes architecture and the workflow. We'll see the various components which gets created during the Kubernetes cluster setup. Also, we'll learn about each components and their respective roles. So let's start. When we create the Kubernetes cluster and do the setups, API server, etcd database, controller and scheduler, these are the components which will be created on the master node. And the kube-proxy, kubelet and Docker daemon will be created on the node machines. So let's see what are the usage of each components. The API server acts as the front end for Kubernetes. The users, management devices, and command line interfaces all talks to the API server to interact with the Kubernetes cluster. etcd database. So etcd is a distributed reliable key value store used by Kubernetes to store all data used to manage the cluster. That is, when we have multiple nodes and multiple masters in our cluster, etcd stores all that information on all the nodes in the cluster in a distributed manner. The scheduler is responsible for distributing work or containers across multiple nodes. It looks for newly created containers and assigns them to the nodes. So it takes all the responsibility to distributing the work based on the workload, and it will first see which nodes is available based on the resource. Then it will just and send instructions to the API server to create the node, to create the containers in the or pods in the particular nodes. So next comes controller. The controllers are the brain behind the orchestration. They're responsible for noticing and responding when nodes, containers, or endpoints goes down. The controllers make decision to bring up new containers in such cases. So kube-proxy. So in the node side, we'll say kube-proxy. Kube-proxy takes care of networking within Kubernetes. In kubelet is the agent that runs on each node in the cluster. The agent is responsible for making sure that the containers are running on the nodes as expected. So the agent will be checking all the status health check of all the containers or pods and then make sure that everything runs fine. Next, the container runtime. So the container runtime is the underlying software that is used to run containers. In our case, it happens to be Docker. So we have used Docker as our runtime environment, which will create containers or pods for us. Okay. So let's move on and see how the entire flow works and how the request comes from the client using kubectl, and then how the API server handles it and sends request back to the scheduler by checking the etcd database, and how the scheduler sends back to the API, and then API sends back to the kubelet to kube-proxy. We'll see in action in the diagram. When the user sends a request through kubectl command line interface, the API server validates the request and sends back to the etcd database. So etcd database notifies back to the API server. Then API server invokes the scheduler, and the scheduler decides where to run the pod and return that to the API server. Then API server persists back those informations to the etcd database. Then what happens? Then API server invokes the kubelet agent on the node side. How it will invoke? It will invoke through the kube-proxy. Okay, so API server will invoke the kubelet through the kube-proxy. Okay, and once the kubelet, then kubelet talks to the Docker daemon using the API over the Docker socket to create the containers. So Docker daemon will create the container. Now once the container gets created, the informations will be sends back to the API server through the kubelet. The agent will send back the informations to the API server, and then API server will persist the data to the etcd database. So now the data or informations are saved into the etcd database. So next time when the user sends back again the request, it will get and fetch the informations from the etcd database through API server and sends back the informations to the user. Now this is what the entire pod creation workflow. Okay, how a pod or when a request comes through the kubectl by the user, how it gets created. Okay. So now you'll be thinking, what is the role of the controller here? So the controller actually is the brain behind everything. So what it does, it scans the etcd database frequently. It does actually the health check. Okay, and if there is anything abnormality found, if any abnormal things happened or anything the controller found, gets the information back from the etcd database and sends back to the scheduler. If there is a pod is down or any node is down, is not responding properly, those informations will be collected from the etcd database and sent back to the scheduler. Then scheduler will take decision what needs to be done. If there is a pod crash, then scheduler will decide and take decision to create the pod again on the particular node. If there is any resource unavailable, like there is resource shortage, then the controller will notify back to the scheduler, and then scheduler will send request to the API server, and it through API server it again comes to back to the respective node, and then the particular actions will be taken care. So that's all about whole architecture and the workflow about the Kubernetes cluster, Kubernetes master and node setup. Hope you understood clearly how the Kubernetes workflow works. And if you have any doubt or any concerns, if you want to know more on that, please do comment me in the comment section below. I'll try to answer your questions. If you have not yet subscribed my channel, please do subscribe now so that you'll get notified when I add more videos on Kubernetes. Thank you.